Good morning. Today is Monday, September 23rd, 2019. If you did not get to attend class today, the recording was not working, so I wanted to just go over what you missed in class with you guys. So starting off with every class, what are we doing, why are we doing it, and how will I be successful today in chemistry? So what we were learning was nuclear fission to understand its role in our lives and how were you going to be successful by achieving your KUD goals. Our goals were to know that nuclear fission is a process in which isotopes are formed, to understand that during nuclear fission, a large nuclei splits into two smaller ones, and then you were going to use chemical equations, definitions, and images to explain nuclear fission within a breakout room. We are still working on the same standard to develop models to illustrate the change in the nucleus of atoms during fission, fusion, and radioactive decay. So we have already had a lab about radioactive decay, so we had a lesson on alpha and beta, and then we followed up that lesson by doing a gizmos lab that specifically focused on alpha decay and beta decay. And so within that nuclear energy realm, we are moving away from radioactive decay and into nuclear fission and fusion today. So I just wanted to have a little bit of a recap about what we did last week and understanding that radioactive decay happens in unstable atoms when their nuclei has too much protons or too many neutrons. And then radioactive decay came in three types: alpha, beta, and gamma. When we talk specifically about alpha decay, we saw on the gizmo that the nucleus emitted an alpha particle, and the alpha particle was just a helium atom. We also saw during beta decay that something different happened here. We didn't emit a particle, we emitted an electron, and that within beta decay, one of our nucleuses, one of the neutrons within the nucleus turns into a proton. In either case, in alpha decay and in beta decay, we form a new isotope. So there is a link here, and it is also in your course content, that has a really cool video explaining nuclear fission. I'm not going to spend time going over that today, so you can watch it on your own. We then had a conversation about what we took away from the video, and people were saying that nuclear fission happens when a neutron is crashed into an atom. That's correct. Nuclear fission has a lot of energy, but it also wastes a lot. Nuclear fission wastes are a problem, and they're very expensive. It's a good alternative for providing energy to us that doesn't emit greenhouse gases. So these are just a few things that people noted from the video. I then went over the main points that 10% of our energy comes from nuclear fission plants. That the process of nuclear fission, and I have an image for you, is when a neutron crashes into a uranium atom, and when it splits, it releases energy in the form of heat. And then a chain reaction of fission is controlled in a nuclear reactor. They're also called reactor vessels, and that allows us to get a constant supply of energy. So scientists are using nuclear reactors or nuclear vessels to crash neutrons into uranium atoms, and that causes heat, and that heat turns into steam. The steam is then used to turn a turbine, and that turbine is used to provide energy to a generator so that we can get the electricity we use in our homes. So this is just a pictorial explanation showing you, like, well, why would we want to dig up our uranium deposits, and why would we want to put atoms inside of a reactor? What's the purpose of it? To meet our energy needs. So that is one reason why nuclear fission is used. And so here is a really great image of nuclear fission. And so like we said, we have a neutron. It's crashed into a nucleus. That nucleus for a very short period of time becomes an unstable isotope. But as you've learned in your gizmo labs, when isotopes are unstable, things happen to them. In this case, they break apart, releasing large amounts of energies, forming two smaller and different isotopes. And then these neutrons go and crash into another product, and this chain reaction basically has it starting back to here. So this is what happens inside of the reactor, and the purpose of this is to get that energy in the form of heat to give us steam to move the turbine so that we can have energy. This was another really great image showing that when your nucleus hits uranium-235, that for a very small point in time, it becomes uranium-236. Do not forget, when we form an isotope, that we are adding a neutron to an already existing nuclei. So that's why this 235 turns into 236, because we have an extra neutron. So then your isotope is formed. It's very unstable, so it splits, breaking up into two smaller nuclei. 3 neutrons go ahead and move that process to keep going. This was an explanation that the nucleons, or protons and neutrons, are conserved during nuclear energy or nuclear change. And so again, we have the uranium-235 turning into an isotope that splits off and produces 3 neutrons. And this is just showing you the infamous chemical equation that you're used to seeing in class. We have uranium-235, a neutron gets added to it. It forms this isotope, which isn't shown in the equation, which is fine, and then those break away into the barium-141, which is here, the krypton-92, which is here, and then your 3 neutrons are here, 1, 2, 3. And if you do the math and you take this mass of 235 plus the mass of your neutron to get 236, those masses, if you add 141, 92, and 3 of these, so basically the number 3 here, you will see that energy is conserved and you end up still with 236 as being your mass. So the mass of the products is equal, the mass of the original isotope and neutron is equal to the mass of the products, because energy cannot be created or destroyed, it's just transformed from one thing into another. So that's what this is representing. And then we had a breakout room challenge, and I shared a slide where you were to give me a definition of nuclear fission, and this person said it's when a neutron slams into an atom and 2 new atoms and 3 neutrons are created. A fact was that 10% of the energy that we use comes from nuclear fission. An example, Bella decided to put a power plant here because she's saying like this is where nuclear fission is happening. And then Taylor said, well, we haven't talked about nuclear fusion, which we will do on Thursday, but this is a non-example of nuclear fission, because in nuclear fission we have that neutron breaking apart. And then in nuclear fusion, we have things fusing together, and this is the process that our stars and our sun, this is what they're doing to get their energy. We then went over what's coming up. So you have a quiz today, please get it done. You have no class tomorrow. I have a boot camp I'm going to be inviting people to if they did not do the quiz. On Wednesday, since my recording wasn't up for today, I'm going to do another session just like today, and hopefully be able to record it. And then on Thursday, we will go over nuclear fusion and then have a quiz. So that kind of completes everything. If you have any questions or comments, please email me. Make sure to do your quiz. All right, thanks guys.